Hello everyone, this is Luis from Point Maximum, and I got another cool project for you. Now let's imagine that it's not winter, as you can see, and instead it's a nice hot summer day. Wouldn't it be nice to have something like this? This is a fan that can power on whenever the temperature gets too hot. Let's walk through some of the features of the project. So the fan that I'm using originally started out as a battery powered fan, but I've made some modifications so that it runs off the current in the circuit instead. Doesn't need batteries anymore. That's because the Arduino, it can only provide 5 volts of 5 volts to the circuit, and that's not enough. I need a secondary voltage source. So that's this one right here. It's coming from an adapter. Now, whenever you're using 2 voltage sources in your circuit, you gotta make sure that they share the common ground. And so that's this bridge here that I made. This is making sure that the ground from the 2 sources is common. And now this here, this is called the BJT transistor. It stands for bipolar junction transistor, and in this particular one that I'm using is NPN. You can learn more about this type of transistor from solid state physics. Now the purpose of the transistor in the circuit is so that I can turn on the fan whenever the temperature gets too hot. So I'm reading in temperature values from the temperature sensor here. The Arduino is analyzing those values. Whenever it passes a certain threshold, it will send a voltage to the transistor, which is like a switch, and this voltage will turn on the switch, allowing the current to flow and turning on the fan. I also have here some diodes. I added a couple of diodes, and the reason why, it's because I wanted to protect my Arduino. This is the first time I've been using 2 voltage sources in the same circuit. I wanted to make sure that all the electronic components are going to be safe, and diodes are an electronic component that only allow current to flow in one direction. So that's why I put those there. Now also another reason why is because whenever you're working with motors, you gotta be concerned about something called the EMF, back EMF. That's back electromotive force. And I got a little setup here to demonstrate what I'm talking about. So I have an LED, and it's hooked up to another DC motor that I have, and I'm gonna rotate the shaft of the motor, and as you can see, the LED starts lighting up. So as you can see, a DC motor, when you rotate the shaft, it actually acts as a generator. So how does this relate to the project? Well, when the fan is on and it then turns off, it's gonna keep spinning due to its angular momentum, and this continued spin is gonna generate some current, and it can possibly go backwards and damage your other electronic components. So that's again the purpose of the diode, making sure that the current is not going backwards. I added one here to be extra safe, but I also have one here in parallel with the motor to make sure that if the current comes out from the motor, then it doesn't go back into the circuit. I also added the capacitor for the same reason as the previous video for the servo motor. I wanted the voltage across the load to remain somewhat more stable, so that's why I added the capacitor there. And the 3 LEDs here are going to be indicating different temperature ranges. When the 3rd LED lights up, that's when the fan will power on, and when it goes out, the fan will go out. So let's go ahead now and demonstrate it. I'm going to touch the temperature sensor, increasing the temperature. LEDs will start lighting up as it gets hotter and hotter. And we got this. This is why I'm hot. This is why I'm hot. This is why I'm hot. Now I'm gonna let go. We're gonna see the 3rd LED is gonna go out, and when it does, so will the fan. Wow, I guess I really was hot. Okay, there we go. Now the fan is off, and that's a success for the project. So I hope you enjoyed it. I hope you liked it. If you're gonna try this at home, be very careful, because whenever you're modifying batteries, like the devices that run on batteries, and you're gonna make them run on the adapters or things like that, it's risky. You only do it if you know what you're doing and if you're very careful. And I hope you enjoy the video. Don't forget to like, share, and subscribe, and I'll catch you in the next one.